Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the relationship between cube root and cubic functions as inverses. Before we do, we need to review a little bit about inverse relationships. Some of this, hopefully you remember from previous lessons. So, inverse relations undo each other. And the reason that's important is because say you have the cube root of x, and you were wanting to get x by itself, you would need to use an inverse relation. So the inverse relation of cube root is the cube function. So if I were to cube the cube root of x, those two functions would undo each other, and I'd simply be left with x. Now, in an inverse relationship, the values of x and y are interchanged. And when we graph a relation and its inverse on the same grid, the two relations are reflections about the line y equals x. Now, we use a symbol for inverse functions that hopefully you've seen before, but it's f to the negative 1 power of x, and it's used to indicate that a relationship is an inverse function. And it's read, when we read it, we say f inverse of x. We don't say f to the negative 1 power. We say f inverse of x. Now, in example 1, it says the graph of f of x equals x cubed plus 1, and g of x equals the cube root of x minus 1 are shown below. Are the two functions inverses of each other? So let me label these real quick. Let's see. This graph is f of x equals x cubed plus 1. And this graph is g of x equals the cube root of x minus 1. All right. Now, what we want to do to see if they're inverses of each other is we need to know, are they reflected across the line y equals x? Are they reflected across the line y equals x? So, for example, if I were to draw, let's see if I can get this to straighten out. This right here, here's my line y equals x. Is each one of those ordered pairs reflected about it? So what we want to do is see, are the x and y switched? So I want to choose a couple of friendly points on the graph of x cubed plus 1. And I'm going to use pink here to indicate that. So there's a friendly point, there's a friendly point, there's a friendly point. So choose about 3 or 4 points, okay? So I want to write those friendly ordered pairs down. So I'll do that in pink also in a table. I'm just going to make a table and list those friendly points. So my one on the left was negative 1, 0. The middle one was 0, 1. And the third point on the right would be 1, 2. Okay. Now, if they are switched, then that means, let me grab a different color here. Grab red, okay? If they are switched, then it's going to look like this: 0, negative 1, 1, 0, 2, 1. In order for g of x equals cube root of x minus 1 to be the inverse, it would have to contain these 3 new points that have been switched. So let's see if it does. 0, negative 1. Yep, that's there. So let me put a check mark. 1, 0. Yep, that's there. And 2, 1, 1, 2, 1. That's there. So because the points have all been reflected across the line y equals x, I know they're inverses of each other. Now let me state that. Let's see. I'm going to grab a different color. Let's see. Yes, they are inverses because each point has been reflected about the line y equals x. All right, let's try another one. Example 2. The graph of f of x equals 2 times the cube root of x, and g of x equals 1/2 x cubed are shown below. Are the two functions inverses of each other? All right, so let me label these. Let's see. Here, this graph is f of x equals 2 cube root of x. And this graph is g of x equals 1/2 x cubed. All right, so now I'm going to pick a couple of friendly points. Let's see, I'll start with g of x equals 1/2 x cubed. I need a couple of friendly points. How about this one? This one and this one, okay? So let me make a table of values here. So the point on the left would be -2, -4, 0, 0, and 2, +4. All right, now if I switch those points, x, y, I would get -4, -2, 0, 0, and 4, 2. So let's see if those points are on f of x equals 2 times the cube root of x. So -4, 2. 1, 2, 3, 4, -2. Whoops, not there. So if your first one is no, that's a no. You don't even have to check the rest of them, all right? So this answer would be no. The points, and I'll just abbreviate that, have not been reflected across the line y equals x. All right. Now, we can also find inverses algebraically instead of graphically. So we have 4 steps we follow. These steps should be reviewed, but we haven't worked with inverses for a while, so I want to just go over the steps again. So when you're finding inverses algebraically, step 1 is to change f of x equals to y equals. The next thing you'll do is switch the x and the y. Then you'll solve for y, and you'll rewrite it in inverse notation. That simply means this. Okay, that's what they mean by inverse notation, all right? So, example 3, find the inverse for each of the following algebraically. So, step 1, replace the f of x equals with y equals, all right? So that's pretty easy. Y equals x cubed plus 2. I didn't really do any math there. I just rewrote f of x as y equals, all right? Step 2, switch the x and the y. So instead of y equals, I'll have x equals y cubed plus 2. Then in step 3, I'm going to get the y by itself. That's what it means by solve for y. So to get the y by itself, I have to get rid of the 2, and then I have to get rid of the 3 power. So I'll get rid of the 2 first. So I'll subtract 2 from both sides. So x minus 2 would equal y cubed. Now, to get the y by itself, I need to use the inverse function. So the inverse of cubing is cube root. So I will take the cube root now of both sides. So cube root this side and cube root this side. All right. So when we do that, that's going to leave us cube root of x minus 2. And the cube root of y cubed is just y. All right, so we've done step 3. We got the y by itself. Step 4, says to rewrite in inverse notation. So step 4. Instead of y equals, I'm going to have f inverse of x equals cube root of x minus 2. And this would be our final answer. So what I want you to do is look back at your original function. F of x equals the x cubed plus 2. And then our inverse is cube root of x minus 2. All right, let's try another one of these. In problem B, we have f of x equals 2 times the cube root of x. So step 1, change the f of x equals to y equals 2 cube root of x. Step 2, switch the x and y. So instead of y equals, you'll have x equals 2 cube root x. Now I want, excuse me, I didn't mean to write x. I meant to write 2 cube root of y. Now I want to get the y by itself. So I'm going to have to get rid of the 2 and then get rid of the cube root. So I'm going to get rid of the 2 first. So I'm going to divide both sides by 2. So when I divide both sides by 2, I get x divided by 2 equals cube root of y. Now I want to write that a little bit different. X divided by 2 is the same thing as 1/2 x equals cube root y. All right. Now the next thing we want to do to get rid of a cube root, we need to cube both sides. So I'm going to cube this side and cube this side. All right. Now, when I cube 1/2 x, that is 1/2 cubed times x cubed. So 1/2 cubed is 1/2 times 1/2 times 1/2, which is 1/8. So this would be 1/8 x cubed is equal to y. Now, last step, rewrite in inverse notation. So f inverse of x is equal to 1/8 x cubed. All right. Now we're going to continue this process with a little bit more advanced problems. In example 4, find the inverse of f algebraically. So we'll follow our steps here. Now, if you want to, you can skip step 1 and you can go straight to switch the x and the y. So instead of f of x equals, we can put x equals y minus 3 to the 3rd power plus 5. Then you can just get the y by itself. So to get the y by itself, I'm going to have to subtract 5 and then take the cube root. So let's subtract the 5 first. This would be x minus 5 equals y minus 3 cubed. Now I want to get rid of the cube, and the opposite of cubing something is to take the cube root. So I'll take the cube root of this side and the cube root of this side. And when I do that, that will leave me cube root x minus 5 equals, and this cube root and this cube will cancel each other out, and I'm left with y minus 3. Now to get the y by itself, all I have to do is add 3 to both sides. So this will be cube root of x minus 5 plus 3. Make sure that plus 3 is not under the cube root though, equals y. And then our last step, rewrite in inverse notation. So f inverse of x is equal to cube root x minus 5 plus 3. All right, problem B. F of x is equal to the cube root of 2x plus 3. So I'm going to start with the step where I switch the x and the y. So x equals cube root of 2y plus 3. All right, I want to get the y by itself, so I'm going to have to do the opposite of cube root, which is raising to the 3 power. So I'm going to raise this side to the 3 power and this side to the 3 power. Okay, so when I do that, I get x cubed equals 2y plus 3. Now all I have to do to get y by itself is subtract 3 and divide by 2. So I'll start by subtracting the 3, x cubed minus 3 equals 2y, and then I'll divide by 2. So x cubed minus 3 divided by 2 is equal to y. And then I want to put it in inverse notation. So f inverse of x equals x cubed minus 3 divided by 2. All right, problem C. We have f of x equals 4x cubed plus 6. All right, let's start by switching the x and y. So x equals 4y cubed plus 6. All right, pause the video and try the rest on your own. All right, let's see how you did. All right, hopefully you subtracted 6. X minus 6 equals 4y cubed, and then divided by 4. So x minus 6 divided by 4 equals y cubed, and then took the cube root. So cube root of x minus 6 over 4 is equal to y. And then lastly, wrote that in inverse notation. So cube root x minus 6 over 4. Now, we can also verify if two functions are inverses. If we don't have the graph, we can use function composition. Now, it's probably been a while since you've used function composition, so we're going to review that. But basically, in function composition, if f of g of x is equal to x and g of f of x is equal to x, then we can say that f of x and g of x are inverses of each other without even making the graph of them. All right, all we have to know is when we compose the functions, do we get x? So let's review how to use function composition. So the first thing I want to find is f of g of x. Now you're going to look what letter is in front. It's f. So if it's f, that means you want to write down this function, but you're going to replace the x with parentheses. You're going to replace the x with parentheses and make the parentheses pretty big here. So this would be cube root of 5 and then big parenthesis minus 10. So instead of 5x minus 10, I wrote down 5 parenthesis minus 10. Now, let's look to see what we should plug in. So it says to plug into the parenthesis g of x. And g of x was 1/5 x cubed plus 2. So I'm going to plug that in right here. 1/5 x cubed plus 2. That's why I had you write it pretty big, right? Now we're going to simplify that. So this would be cube root. Now we need to distribute the 5. 5 times 1/5 x cubed is 1 x cubed. 5 times 2 is positive 10, and then we have minus 10. Now, if we simplify that, that would give us the cube root of x cubed. Now, what is the cube root of x cubed? Well, the cube root and cubes undo each other, so this is equal to x. All right, now we want to find g of f of x. G of f of x. So look to see what letter's in the front. Since it's g, you're going to write down the g of x function and replace the x with parentheses. So instead of 1/5 x cubed plus 2, you're going to write 1/5 big parenthesis cubed plus 2. So 1/5 big parenthesis cubed plus 2. Now, what are you going to plug in? Well, it's right here. You're plugging in f of x. So f of x is cube root of 5x minus 10. All right, now we'll simplify that. So this would be 1/5. Now the cube root and this cube are going to cancel each other out and leave us 5x minus 10. And then out to the side we have plus 2. So we'll simplify that. 1/5 times 5x is just x. 1/5 times negative 10 is negative 2 plus 2. Now the negative 2 plus 2 is 0, so that leaves me x. So if you get an x here and an x here, yes, they are inverses of each other. Okay, yes, they are inverses of each other. All right, look at problem B. We have f of x equals 8x cubed, and g of x equals 1/2 times the cube root of x. So I'm going to start out by finding f of g of x. So f of x is 8x cubed, and I want to replace the x with a big parenthesis. Okay, so instead of 8x cubed, I'll have 8 parenthesis cubed. And into that parenthesis, I'm going to plug in g of x, which is 1/2 times the cube root of x. Now, according to our order of operations, we want to do the exponents first. So drop the 8 down, and we want to do 1/2 to the third power, which we already learned was 1/8, and then the cube root of x cubed is just x. So 8 times 1/8 is just 1x. All right. Now let's find g of f of x. So I will write down my function, 1/2 times the cube root of x. But instead of x, I'm going to plug in 8x cubed. All right. So 1/2 times the cube root of 8 is 2, and the cube root of x cubed is just x. So the cube root of 8x cubed is simply 2x. Then you'll multiply those together. 1/2 times 2x is just x. So we got an x there and an x there. So yes, they are inverses of each other. And that concludes today's lesson, cube root and cubic functions as inverses.